and now we are moving to PLASTNIR Project, automatic detection systems for industrial thermoplastic processes based on NIR and multispectral technology. It will be presented by Juan Gomez. I think we have you here, Juan.
Hello. Good morning. Yes.
Good morning.
Sorry
You're going to
sorry for the simultaneously profiles, but my camera from the laptop is not working, so I connected with my handphone also.
No problem. And
I hope you can. I hope you can hear me properly. I understand.
We can hear you perfectly. And are you going to share your presentation?
Yes, please. I would
have the controls. I'm going to briefly introduce you to the audience meanwhile. So Juan Gomez Garcia has a diverse background in industrial engineering, having studied in Jaén, Toulouse, Munich, and Utah. His career began in research focusing on industry 4.0 topics as part of the University of Jaén research group in robotics, automation, and artificial vision. He then transitioned in the corporate world, working in hardware design and management at companies like Everis, NTT Data in Madrid, and EBS in Frankfurt. And currently, he is co-CEO of the ISR, the company that is actually implementing this project, where he previously contributed to business development team. So, Juan, the floor is yours, and the audience is also.
Okay, thank you very much. Well, first of all, since we are, I think, the third system or project related with spectral and classification for plastics, I hear my colleagues, both Clara and Alvaro, congrats for the results, because they seem they have achieved quite confident results. So from our side, at the end, as you mentioned, we focused from the beginning of the project on using spectral technologies. We were willing to use just multispectral. I think, or maybe I will just introduce what is the difference between multispectral, hyperspectral, and monochrome, where the near spectrum is between. But during the development of the project, we have been dealing with some different issues. So at the end, what we expected from the beginning till what we have achieved at the last point of the project now has been drafting. That is something quite common on this kind of projects. So first of all, I would like to make a really brief introduction of what we do, because it's also a really good explanation of how have we proposed, or how have we developed this project. At the end, we are developing solutions for different industrial sectors, such as agroalimentary or automotive, steel, aeronautical. But at the end, the focus of the company and the vision of the company is developing solutions for inspecting quality in the processes, but always in automatic mode, online. So using this as a base, where we came to the project of INCIRCULAR, we understood that it was a really nice opportunity to introduce the solutions we are using at the end, technologies, to the process of recycling plastic. That's the point where we came to the project proposal we made, that it was PLASTNIR. PLASTNIR is a project where, I repeat again, is similar to the concept my colleague Clara and Alvaro has mentioned, but I could say that we are kind of in between both, because since we are a company that is based on classical computer vision from 10 years ago that we studied, of course we have been growing up, and now, of course, we cannot understand computer vision from today without AI. But also at the same level, for example, of importance, nowadays we have to also include not just what is visible. I mean, computer vision, but with visible spectrum. But we have to also work with spectral solutions. So that's the point we came to this PLASTNIR project, where we use first classical computer vision for first pre-processed images, and then we use all the mask and all the important data we get from the images processed with a spectral solution. The aim of the project is quite similar from the other projects and from the INCIRCULAR project by itself. It's trying to make this process of recycling much easier and with lower costs. So today there are some solutions that may be kind of usable for these cases, but at the end they are quite expensive. And then they have kind of tech limitation regarding the plastics that they can detect, but also the implementation of the system. So we were willing to do something that it would be possible to be integrated for all kind of companies, where also SME small companies could also afford to implement. So also we expected to have this impact regarding both in the processes by itself of recycling plastics, but also what I've mentioned, that is that we could get to a solution that can help the industry and the market. At the end, the objectives when we got the project were classified, for example, for in different aspects. But the main points there was like to provide the low cost system, as we mentioned before. That can be done because of the knowledge we have from the beginning of the ISR company, because we focus on trying to do this kind of developments. But also in second place, doing with high precision. Okay, this has been possible also regarding also using different kind of technologies, not just one. And of course, trying to do all these low cost prototype with high precision with a industrial validation. Okay. So at the end, what we have achieved at this point of the project, we have done two kind of versions for the system, because we started with multispectral and we end up using also hyperspectral. At the end, the point of this is that multispectral, as we planned from the beginning, has some limitations, but we wanted to try to get all that we could, and of course we got really kind good results, but of course we have some limitation. So that was the point where we also decided to use also a multi hyperspectral that could give us a plus to achieve all the points we were willing. Okay. So basically, we did a system design at first, because we did test for this process of industrial industry. So we did a prototype like this one, this image on the bottom. We start taking data that we were also able to do it thanks to group Andaltec, that is also from here, from Andalusia, and they are a technology center for the plastic. So they helped us to achieve all these kind of plastics and to understand how they performance in terms of chemical and parameters that we could try to see through the spectral solutions. And then, of course, we start working with machine learning models and trying to see tendencies through different kind of plastics that could give us predictable models that end up to a final solution. As I mentioned before, basically what we have doing or we have done as a methodology has been working in parallel with two different technologies. Uh, but at the end, they are the same technology, but with different scope, we can say. Of course, we have been validating different steps we have been doing, both by ourselves, of course, with the INCIRCULAR team, and of course, with Andaltec, that has been also giving feedback to us. Um, so here we have some results that we have achieved. At the end, as I mentioned before, we use first classical algorithms for computer vision to detect all the components, all the interesting components in the images, because at the end we understand from the beginning and from our expertise that all the information that is in an image that you are not going to inspect it's not usable to have it in your testing, since they can give deepness to the data. So at the end, we try to use first classical vision to detect this. After that, we apply algorithm for using multispectral and hyperspectral cameras, and both normally used in near region. Okay. That is the region that is near the infrared as usual. We have some result of the matrix confusion matrix for both system. As we can see, the multispectral has some limitation, but in general it has also really good results for some kind of plastics. But here, for example, for the PA and the PP in different colors, we had some difficulties where in the hyperspectral we didn't have. At the end, is hyperspectral, of course, it's more powerful. But of course, as all the our colleagues mentioned also, and we as we plan, we still need to continue working on black plastics, since they are the most difficult ones to see. So we are trying to use, at the end of the project, we did some tests that they are not still sufficient, but we need to still continue on that, but using different lightings, systems, etc. Okay, so at the end, when we had this conclusion for the technical part, we understand that the market solution needs something that there is not still. So the first part is just giving a solution with multispectral and hyperspectral with low cost. Okay, so that is something that we are working, but we think we get to a point where we are really comfortable to go with. And of course, giving the high quality precision on terms of inspection. What is the the gap we are trying to fulfill at the end? Again, giving solutions for not really big companies that can be affordable, that also don't need really big investment projects, both in terms of costs and in terms of integrations. Okay, so what is our business model? This is also something that we are really used to do it in all the sectors, but we would like to work with two factor or two blocks model. First one is the system by itself, that is the capex. We understand from the industry that it's really useful for them to introduce the capex as a one solution. But then we are working with all of our solution with SaaS services. At the end, it's the OPEX, where we give the license, for example, for the software to the customer. We get annual revenues, recurrent revenues. That it's helpful for us, and also give us the possibility to update the software and the solution every year. So that is also a really good point for the customer. So The next point we are trying to plan is to do a pilot validation. Probably we'll do it with someone related with Andaltec. Then, of course, making effort in understanding the market and doing some commercial marketing and trying to do business investigation. And then, of course, we will try to in the next 3 5 years try to go to the market where we understand and we search that we could get to a 5% market share. Um, as impacts, we mentioned before, but at the end we have like three main blocks: environmental, economic, and industrial. I think both in economic and industrial impact, I think I've mentioned a lot. I will focus now on environmental, but uh, we can give a lot of really good results in not wasting kind of valuable plastics that couldn't be burned and could be reused, but also we can also reduce the cost of all this recycling. Again, I think in economic impact, I've mentioned a lot. Industrial impact is the same. I think we can give a solution that both in economic and in integration in industrial terms can be affordable for all the companies. And our next steps, what we are planning, what is our vision and perspective, is the same. We want to continue with the plan I mentioned. We want to try a pilot deployment in industrial site. We want to understand better the market because even we have done some research. We would like to start asking customers, fixing prices, but now with the customer real conversations. And if everything goes as planned, we plan to in the next 3 5 years start selling this solution and trying to grow with it. So thank you very much. That's everything from my side.